All right, so today we're going to talk about solving systems of equations. We're going to spend a couple of weeks on it, but today we're going to discuss how to solve an equation or solve a system by graphing. But to do that, I want to review again how to graph an equation in slope-intercept form. So remember, this is your slope-intercept form, y equals mx plus b. M is your slope, the y-intercept is your is b, the constant, okay? So whenever we talk about slope, we talk about this as rise over run. It's the change in y divided by the change in x. It is how far you go vertically divided by how far you move horizontally. And remember, directions matter. They could be positive or negative. So the y-intercept, b, is where you cross the y-axis. Let's put that there, okay? Remember, m and b are only numbers. You do not include x when you talk about the slope. All right, so let's review again how to graph an equation in slope-intercept form. You identify the y-intercept, and then you plot the point 0b. So again, we go on the y-axis, and it goes there. I should say that, on the y-axis. Step 2, you use the slope m to find a second point. That will be the rise divided by the run. You always want to make a whole number over 1, or you want to put a whole number over 1 to make it a fraction, because remember, we need a rise and we need a run. And then you'll connect the points to make the line. So I guess we should review a few things as well while we're here. When we talk about slope, when we rise up, it's positive. When we rise down, it's negative. And whenever we discuss the run, when you run to the right, it's positive. And when you run to the left, it's negative. So let's see if that helps us any. Hopefully it will. Now, as discussed, slope being positive or negative makes a big difference. If you mess up a sign, it messes up the whole line. And you'll kind of see that as we go through. So for example, 3/2 or 4, those are a positive slope. Think about what happens from the left to the right. Whenever we have a positive slope, our line rises from left to right. It goes uphill, okay? We also say that that is increasing. You earn $10 an hour. You save $50 a month. Things like that. A negative slope falls from the left to the right. You'll see that as -1/2. Now, the cool thing here is this negative can either go with the 1 or it can go with the 2 whenever you start rising and running. And remember, -4 you'll treat as -4/1. This goes down a hill. So when you look from left to right, it goes downhill. It's decreasing. So whenever you're graphing a line, if you see that it has a positive slope and it goes this way, you've done something wrong. You'll want to look it over. Positive slope goes up a hill like this. It could be a very steep slope. It could be a very narrow slope. But as long as it's going up a hill, we're good. Same thing here. If I graph a line with a negative slope, it better not look like this. For real. It needs to look this way. Okay, it needs to be decreasing. Then we talk about lines that have 0 slope. The y coordinates are all the same. Think about what you're doing. You're actually traveling in a straight line, flat land, basically. There is no vertical change. And here's the thing that I want you to notice that we're going to talk about. See right here where it says y values are the same? Well, the equation looks like this. Y equals something. And this will be just a number, a constant. There is no x, so we're on flat land. Whenever we have an undefined slope, it's basically a vertical, you run into a brick wall. There is no horizontal change here. When we look at this one, notice the x values are all the same. This will be x equals some number. You know, like x equals 2, x equals 5, whatever the case may be. So those are the things that you sort of need to keep in mind whenever we start discussing that. You will see it soon, okay? All right, and yeah, I did say that's a constant. All right, so let's actually practice some, shall we? And I'm going to do this a little crazy. I'm going to go over the steps with you, and then we'll go through in a different order. So whenever you solve by graphing, since I never discussed the intercepts method with y'all, you will want to make sure each equation is in slope-intercept form, y equals mx plus b. So remember, that's your y-intercept. So you'll plot the y-intercept, and then you'll rise and run. Okay? You will graph each equation on the same graph paper? Nah. I want to use the proper terminology. You will graph them on the same plane, the same coordinate plane. The point where the lines intersect is the solution. If they don't intersect, then there's no solution. What does a line look like? What do lines look like when they don't intersect? Oh, they're parallel lines. And then you'll want to check your solution algebraically. So if you notice here, right now only one of these appears to be in slope-intercept form, and it's this one. So I think I'd like to do this one first. So I have to go into a little bit of a discussion, so y'all bear with me. In class, when we work through these together, I would give you 2 different color pencils so that you can graph one line in one color and the other line in another color, and then you can sort of see the difference. I think it's good practice for you so that you can look at your line and troubleshoot, and we can say, like, if you don't get something or you don't like it, I can ask you, all right, which line is this? And you can pick it out right away. So I will use different colors to graph these. However, on the end of course test, I'm not allowed to give you color pencils. I'm only allowed to give you a pencil, well, 2 number 2 pencils. So I'm going to show you what I do to make my lines make sense. Now I'll use pretty colors today, but I'm also going to use just a regular pencil. So I'm going to call this equation A. And I'll actually do this whenever we discuss substitution. So when I look at equation A, my y-intercept will be 5, and my slope will be the number in front of x, -2. But remember, whenever we're dealing with slope, we want to think of that as a fraction. So it's -2/1. Okay, so I think I want to do this one in pink. So let me graph this. So for this one, my y-intercept is 5. My slope is -2. So I'm going to go down 2 and to the right 1. Down 2 and to the right 1. These are pretty handy for these small grids. And I plot every single point. Number 1, because I'm extra. Number 2, because sometimes your ruler slips. Sometimes you put a fat point of a pencil against a ruler and it sort of changes it. For example, here, this part of the line isn't exactly on the lattice point. It's not on the point either, so I may run into problems. But I will remind myself that that's line A, just in case I'm using pencil. All right, the next one, we'll call this line or equation B. Here, my y-intercept is 1, and my slope is -2. My slope is -2 divided by 1. So I'm going to look at this one in purple. My y-intercept is 1. My slope is -2 divided by 1. Okay, right now we're sort of matching move for move. Hopefully we'll intersect up here. Up 2 to the left 1, up 2 to the left 1, up 2 to the left 1, up 2, no. Okay, what's happening here? Well, these lines are parallel. What does that mean? That means they won't intersect. What happens when they don't intersect? If they don't intersect, then there's no solution. So guess what? Right here, we have no solution. And you can actually see this one point for point, how nothing meets. And I'll tell you, if I were giving you a classwork assignment and I had to make the key, if I don't have a ruler on me, or if you don't have a ruler on me, plot every single point, because then you can see the behavior of the line without drawing the actual line, for real. So look what happens here. Nothing meets. So that means this equation has no solution. Well, why does that happen? Do you notice anything? I mean, I notice it. Look right here. They're rising and running in the same direction at the same places. So they will never meet. Whenever you have equal slopes, you're going to have parallel lines. So file that away for a rainy day. All right, let's look at number 4, because again, these aren't in slope-intercept form. Equation A is already set up for me. Now, according to this, we have just y equals. That's a horizontal line. Horizontal line, remember, looks like the horizon. Think of this, it's y equals 0x plus 5, and my slope is 0. That's what's happening. And the previous notes, the back page of this said when you have a slope of 0, you've got a horizontal line. That's one of those things that I recommend that you memorize. Okay, so I'm going to plot this equation in pink. So when y equals 5, I'm going to go here. My y-intercept could be 5. My slope is 0. And again, if I didn't have a ruler, I would painstakingly plot every single one of these. All right. So here we go. That's what the graph looks like. That's for equation A. Now let's look at equation B. I see that this is not in slope-intercept form, but I can make it in slope-intercept form. And in order to do that, I need to solve for y. In order to solve for y, I'm going to subtract the 2x from both sides. When I do that, I get y equals -2x plus 1. And for this equation, I'll call this equation, well, it's still equation B. My y-intercept is 1, and my slope is -2. Oh, I just did -2 up there. So I know that that's -2 divided by 1. And I'm going to graph this line in purple. All right, so here we go. Let's see, my y-intercept is 1. My slope is -2 divided by 1. So when I'm plotting this way, remember, I want to know what happens with the purple line and the pink line. I'm going away from the line, so nothing's happening. So I bet I have to go in the opposite directions. Oh, there it is. And when I plot this way, I do see that they intersect. But remember, this is solving by graphing, so I have to make sure my graphs are correct. It's just one of those things. This is equation B that I'm graphing. So where do these two intersect? Well, they are intersecting right there. So I start at the origin. I go -2, 1, 2, 3, 4, 5. So the order pair is -2, 5. Okay. I have a solution. I think it's going to be -2, 5. Well, let's check it, okay? Normally I would tell you to use your calculator for this, but I can't seem to put my hands on a calculator right now. So I may in the meantime. So let's check it. So in equation A, y equals 5. Well, does the y coordinate equal 5? Yeah. All right, so let's look at equation B. I have 2x plus y equals 1. So let's take 2 times negative 2 plus 5. Does that equal 1? Well, that's negative 4 plus 5. 1 equals 1. Oh yeah, that one checks too. So that checks, that checks. So guess what? I know that's the correct answer. That's how you check your work, y'all. And you know, whenever we start doing these, if it's multiple choice and you can't figure it out for the life of you, choose A, B, and C and D. Put the coordinates in, you know, the old plug and chug. All right. Now let's come back to number 1. Now that we've seen a slope-intercept form, now that we've done one that has a solution where we had to rewrite our equation in slope-intercept form, let's look at this one. Now, y'all know I'm lazy, so I would not use slope-intercept form for this. I would use the intercepts method, Google intercepts method, or maybe down the road I'll make a video on that. But let's just write this in slope-intercept form, shall we? So equation A, I have 2x minus 2y equals negative 8. So in order to solve for y, I'm going to subtract the 2x. When I do that, I get negative 2y equals negative 2x plus 8. Then I'm going to divide by negative 2. And when I do that, I get y equals 1x minus 4. And in real life, y'all, I wouldn't put the 1 there. I'm putting it there for y'all. So let's see what we know. I know my y-intercept is, I almost made that same mistake again. Okay, the y-intercept, number 1, it would help if I wrote it correctly. I caution y'all all the time not to drop negatives, and I just did. So this is actually y equals x plus 4. So my y-intercept is 4. Let's get rid of that little thing there. All right, and my slope is 1, which will be 1 divided by 1. And I will use pink for this one. So my y-intercept is 4. So on my y-axis, 1, 2, 3, 4. My slope is 1 over 1. So up 1 to the right 1, up 1 to the right 1. Notice I'm taking every diagonal. So I've graphed my first line here, and I want to make it Facebook official. So I actually need a line. And again, in a color pencil, a non-color pencil world, I would label that so that I know where it is. All right, and now I want to graph my second equation. I'm going to call my second equation equation B. And again, this needs to be in slope-intercept form. So this one needs to be solved for y. And I'm just going to do the work here because I'm a dummy and I didn't leave enough room. So we're going to subtract the 2x on both sides. And when we do that, we get 2y equals negative 2x plus 4. And now I need to divide by 2. And I'm just going to do that in this step as well, because why not? When I do that, I get y equals negative x plus 2. All right, what do we know here? I know that my y-intercept is 2, and I know that my slope is negative 1, which is negative 1 over 1. Oh, that's a little sloppy, but it's clearer on the notes, I believe. So all of this information we're going to do in purple. So my y-intercept is 2. My slope is negative 1 divided by 1. And look what's happening. I am nowhere near the pink line. Okay, so Going that way is a moot point. So I need to go in the opposite directions. So instead of going down and to the right, I'm going to travel up and to the left, and oh, there it is. And I'm going to plot these points just because I can't leave it unfinished, you know? All right, so again, I have to make a line. A word of caution, y'all. If the directions ask you to solve by graphing, I need to see a graph. Don't magically solve it some other way. I mean, I would do it, but then I would work backwards, you know, and try to remember. All right, so there's my intersection point. It appears to be -1, 1, 2, 3. I've got to have a calculator somewhere. So I think my solution is -1, 3. So now I just need to verify it. I need to check it by plugging it in. Oh yeah, here we go. Excellent. All right. All right, so it looks like I want to use -1, 3. So I'm going to let x equal -1 minus 2 times 3. I should get -8. I did, yes. So it checks there. And now let's try the second one. 2 times x, which is -1, plus 2 times y, which is 3. Let's get 4. Boom, got 4. So guess what? This is correct. Okay. All right, so there we are. I had one solution. I checked my solution algebraically. Everything's good. All right, so now let's look at this last one. I've got x plus y equals -2. And again, that's not in slope-intercept form, but I'm going to make it in slope-intercept form. So if I have x plus y equals -2, I'm going to subtract the x, and I get y equals -x minus 2. So my y-intercept is -2. My slope is -1, which is -1 over 1. All right, so let's check out this one. Again, I'll go pink. Okay, my y-intercept is -2. My slope is -1 divided by 1. So I'm going to plot these in. And you know, on the EOC, we're not allowed to give you a ruler, but you can always make a straight edge. You can fold your scratch paper if you want to draw a straight line, but you can always fall back on just drawing a series of points. I mean, if I see those points and I make them thicker if I wanted to, I can see the line. I can sort of envision the line that goes there. I mean, you know, that's better than nothing. So these are little tricks to keep in mind. We may have to look at some test-taking hacks down the road. That's equation A. All right. Now let's look at equation B. And I was smart, and I left myself some room right here. So equation B will go here. 2x minus 3y equals -9. So remember, I need the y by itself. I'm going to subtract the 2x. When I do that, I get -3y equals -2x minus 9. And now I'm going to divide everything by -3. And I get y equals a positive 2/3 x plus 3. Because when you take the -9 and you divide it by -3, you get a positive 3. So my y-intercept is 3. And my slope is, oh nice, 2/3. I didn't have to turn anything into a fraction. It was already a fraction. And we will graph equation B in purple. So my y-intercept is 3. My slope is 2/3. And nothing is happening up there. So I need to go towards the line. That means we need to go down 2 and to the left 3. Oh, there it is. But let me finish this line. Okay, so on an EOC, I would get to that point and say, hey, there's my intersection point. You don't have to finish the line, but if I'm going to do something, I'm going to do it right. And I'm going to do it completely. So there's my line for my second equation. And I know that my ordered pair solution will be -3 and then up 1. Does it bug me that all of my solutions are to the right of each graph except for this one? A little, but that's okay. It doesn't matter. I want to check it, that's for sure. All right, so does x plus y equal -2? Does -3 plus 1 equal -2? Yes. So that one checks. Now, does 2 times -3 minus 3 times 1, does that equal -9? Yes, it does. So guess what? That means this is the right answer. I checked it, so I box this one up and take it home. It's good. Okay, so in review, write your equations in slope-intercept form, graph them, and then look at the lines. Even before you start graphing, there are certain things you can figure out. For example, if the lines have the same y-intercept b and the same slope m, guess what that means? That means they're the same line. And when your system is basically the same line, just written 2 different ways, your system has infinitely many solutions. Basically, you're going to trace a line onto itself. I think on the practice sheet that I give after this, there is one that it's in slope-intercept form, it's in standard form, you get the same line. If the lines have the same slope m, but different y-intercepts b, did we do one like that? Yeah, we did, and I conveniently circled it for you. Look here, same slope, but different y-intercepts. What happened? We had parallel lines. So this happens with parallel lines. This is no solution. If the lines have different slopes m, well, that means one line can travel this way, one can travel that way. You could have an undefined slope with a 0 slope. I could have a very almost flat positive with a ridiculously steep positive. Anything like that works. So when you have different slopes, they're going to intersect at one place. This system has one solution. I mean, so here, parallel, same line, you'll see it traced on top of the other, But that's everything you need to know about solving a system by graphing.